Okay, in class we looked at plotting polar coordinates, and we talked a little bit about it graphically. In the textbook and the homework in my math lab, they ask you to find other sets of polar coordinates that are the same point, and they emphasize it a little bit more than the old textbook did. So I just wanted to make sure, even though we did it visually, that you guys understand how to compute that. So if we graph the point 3 pi over 3, so that means radius 3, let's say like that, and then we rotate pi over 3 like that maybe. So that could be the point 3 pi over 3. Okay, but there are other ways to describe that same point. So obviously this would come into all of your coterminal angles too. So if you remember way back when we talked about coterminal angles, you could add or subtract 2 pi, and that's going to land you in the same spot, just like it does on the unit circle. So you could do, if theta is pi over 3, you could also do 2 pi plus pi over 3. That's going to give us 6 plus 1 would be 7 pi over 3. And then you could also subtract 2 pi, or a negative 2 pi plus pi over 3. So that's going to give us 5 pi over 3. Sorry, negative 5 pi over 3. Okay, so 3 pi over 3 is the same as 7 pi over 3. Okay, because that takes us around 2 pi plus another pi over 3. And that's the same as negative 5 pi over 3. Okay, so that's just using coterminal angles to find another value for theta. Now we also talked about the fact that if r was negative, it goes the other direction. So for example, we could come around opposite along here, okay, and this would be this would be negative 3 pi over 3, like that. Okay, so we looked at what a negative r did to it. Now how would we find, here let me put it in another color so we see it. I don't want to find a different point, I want to find this same point. How do we find that point in red with a negative r? Okay, so that we didn't actually do, and I think that you guys could probably figure it out if you played around with it a little bit. But the idea here is that negative would bring us around to this side, and we need to get the angle that brings us back around to the original point. So in order to be across from that, it's going to have to be 180. So if we want r to be negative 3, we're going to have to take our pi over 3 and add or subtract 180 or pi to it. Okay, so let's see what that does. So that's going to give us 4 pi over 3. And that's this angle right here. Okay, so this point is the same as 4 pi over 3. So see how that works? Negative 3, positive 3, and then you add 180. But that's not the one that we want. We want this one over here. So we want negative 3, 4 pi over 3. Okay, so you'd go around 4 pi over 3 and land on this other point that we don't want, and then the negative 3 would take you the opposite direction over to here where you do want it. Okay, so to get the opposite angle, the negative r, you're going to add or subtract pi. So if we want another one for r equals negative 3, we could take our theta and we could subtract pi from it. And that's going to give us negative 2 pi over 3. Okay, so let's try another one. All right, let's try one with degrees. Let me go back to black here. Let's say we have the point 2, 120. Okay, 2, 120. So our radius is 2, and we're going to rotate around to 120, which is right about here. Okay, so radius 2, point 120. All right, so let's try to find 3 other angles three other polar coordinates that would give us that same point. So we could take our theta is 120, and we could add or subtract 360 to it. That would give us our coterminal angles. So another theta would be 120 plus 360, and that's going to give us 480. And another theta could be 120 minus 360, and that's going to give us negative 240. Okay, so that gives us a couple options right off the start here. Okay, so 2 480 and 2 negative 240. All right, so that's just a matter of doing coterminal angles. Now, what if we want R to be negative 2? What angle would we have to have for R to be negative 2? All right, so we want the angle that is directly opposite 120. Okay, we want the angle that's over here directly opposite 120, so we're going to add or subtract pi to it. Sorry, 180. We're in degrees now. So we're going to take 120 plus 180, and we're going to take 120 minus 180. That gives us two options for angles that are directly across from 120. So adding them gives us 300, and subtracting them gives us negative 60. So that gives us two more polar coordinates. Negative 2, 300, and negative 2, negative 60. Okay, so let's check those. So let's do negative 2, 300 first. So the radius distance is 2. We'd go around to 300, which would put us right about here. And then negative 2 tells us to go the opposite direction, and that seems reasonable. We land at 2, 120. And then the same thing for negative 260. We rotate around this way, and then the negative 2 takes us the opposite direction. Okay, so that's how you find the equal coordinates. You add or subtract 360 or 2 pi to get the coterminal angle, same radius, and you add or subtract 180 or pi to get the angles that, to get the angles that go with the negative radius.